Utilizing lighting at maximum efficiency with the illumination levels necessary to do the job can be achieved by selecting and using the proper controls. What type of controls, how convenient they are, whether or not they are automatic, where they are located, and what they can do have a vast influence on how effectively the energy required for lighting is being used. Controls should be selected to fit the end use of the installation. Lighting circuits can be controlled by having conveniently located switches installed based on the type of occupancy of the area. In some cases, it is more desirable to install contactors to control the lighting system instead of individual circuit switch control. Large lighting systems of industrial, office, store, and exterior areas may require an entirely different type of control of the lighting system than smaller areas. Virtually any light source in any lighting circuit can now be controlled by dimmer switches. A dimmer switch allows design for peak lighting needs with the ability to set the illumination at the level desired at a particular moment. Energy consumption is reduced and lamp life is often increased. The figure on the right illustrates the relative efficiency of 175-watt and 250-watt HPS lamps under dimmer control. The photoelectric switch is designed to turn lights off or on when ambient light levels reach a predetermined level. These switches allow automatic control of lighting, such as outdoor roadway lighting, parking lot lights, and indoor lighting where there is a large window area that can be utilized as part of the ambient lighting. Photoelectric switches allow considerable savings in energy because they turn the lights off automatically when they are not needed. They can be used in conjunction with a time clock to control turn-off time, for example, on at dusk and off at midnight. A time clock-controlled contactor switches lights on and off in relation to the time of day. For example, the lights can be turned on automatically at 5 p.m. and turned off at whatever time is selected. It is fully automatic and saves electrical energy because the lights will be turned off when not needed. Electronic sensing devices may be used to activate areas of a lighting system. These systems utilize changes in heat, sound, light, or movement within the area. Applications include conference rooms, warehouses, and parking lots where lighting is needed only part of the time. Electronic sensing devices are automatic on-off devices that can save energy in areas where employees are not present for a portion of the day or night. These devices detect the presence of a person and, in response, turn the light on in that area. Microprocessor-based lighting controls minimize the dependence on people to operate the lighting system. These automatic controls consist of three basic components: an input device that includes sensors, timing devices, and input signals from other building systems, a processor that takes information from the input device and determines the appropriate state of the lighting system, and a controller that connects to the luminaire and adjusts the power delivered to provide the light level determined by the processor based on the sensor input. Automatic controls can conserve energy and save money. This image shows two examples of the impact of combining use of daylight and electric light in a given day. The different lines depict portions of daylight and electric light illuminance. The top line indicates what happens to the overall illuminance in the space. The top curve shows abrupt changes in the illuminance, as in timing controls and switches. These methods can be used effectively in non-critical task areas, such as cafeterias, corridors, or warehouse areas. The bottom method provides continuous control of light level and can be used in any daylighted space. It may be a better choice for critical task areas.